Welcome to Section 5. In the previous sections, we talked about many code-level features that make our code reusable. In this section, we're going to zoom out and look at how we can organize this code into reusable packages, or crates in Rust terminology. We will also look at how to organize the namespaces inside a crate, so we can have a clear hierarchy of our code. Luckily, all these operations like packaging, reusing, and publishing crates are managed by Rust's cargo tool, which is a package manager similar to Node.js NPM. So you don't have to do this all by yourself. So let's first take a look at crates. Crates is a package or module or library in other programming languages terminology. Crate is the basic unit of package in Rust. So if you go to crates.io website, you will see a lot of crates created by the Rust community. There are useful libraries like random number generators, regular expressions, and there are also binary programs like command line utilities. So how do we create a crate ourselves? The cargo tool gives us a new function. There are two variations of a crate, the binary crate or the library crate. Binary crate is usually an independent program, like a command line tool, or any other program that has a graphical user interface. And library crates are just a set of functions or classes that you can reuse. You can expose algorithms in a library crate. So we can run these two commands and create two example crates. So let's take a look at how Cargo will create for us. Cargo created two folders, example binary and example library, and it pre-populates some files that is useful to structure our crates. First, we will see they both have a cargo.toml file. This contains metadata like the name, the author, the version of this crate. And for binary crate, it will create a source code folder, and then underneath it will have a main.rs file. This is the main entry point for your binary program. You have to put the main function inside it. And for library crate, it creates a lib.rs file instead. Usually that is your main interface to expose your functions or structs. So you can write more code, but usually you expose the main interface in lib.rs. Let's first take a look at a binary crate. So the cargo.toml file will have the name of the package, the version, and the authors. And you can specify dependencies, which we will talk in later videos. The main.rs file is where you put the main function. To compile and run this main.rs file, we don't use the Rust C directly anymore. We use the cargo run command. This will compile the code and run the main function. As you can see, we print out the hello world line. And for library crates, we have nothing to run, so we usually just run cargo build. This will compile the lib.rs file. Can usually catch some errors, which the Rust C compiler will catch for you. If you look at the example lib.rs file cargo gives you, it also contains a set of unit tests. So with this test attributes, these functions are actually unit tests, which will not run when you execute the main library. But you can use cargo test. This will scan through your crate and run all the unit tests it found. So if we look at cargo help, there are many useful tools like test, benchmarking, or you can also do like update dependencies, search, publishing, and install your binary program on install. These things are all provided for free by Cargo. We don't have the time to go into detail each one of them, but we will talk about publishing in the later videos.